now. Can you see me?
Yes, very good.
Wonderful. So thank you everyone for joining, and I will be talking you about our project, which is ALPS, Automated Licensing Payment System. I've chosen, given the little time, to have more of a bird's eye view of our main idea behind. So this talk will go on with first highlighting the problem that we're trying to solve, then a little bit about the tools that we're going to use, and then our solution, our proposal, and mainly to, let's say, spark discussion. So you can see if this is applicable in your case. So what is ALPS about? ALPS is about license agreements. So of course, many of you probably are very familiar with license agreement. We have a licensor, which is the inventor, the creator that has a novel idea and wants to, let's say, to be remunerated for this idea by a licensee, which is the entity, so the company that uses such IP, such intellectual property, to build a device, and then of course sell the device, make money from it. What are the problems of today's today? So the standard system of how today license agreement works. Basically, we have it's not very, let's say, very modern as a system. Much of the operation are still manual and are still cumbersome for both parties. How it works is that we have an agreement on some royalties to be paid, and those royalties depend on some royalty base, which needs to be managed and computed on the licensee side. Of course, these information, such as the number of devices manufactured, for example, as royalty base, this is confidential information that the licensee does not want to reveal to the licensor directly. And so the licensor itself receives the royalty, receives the payment, but has no way to verify that those are the proper and correct payments, unless he wants to perform some audits on the royalty payment, which of course are costly, create bad mood between the parties, and so have a lot of disadvantages for both, and of course often take a long time with small gains. And this also means higher transaction costs, and what in practice all this implies is a big problem of trust between the licensor and the licensee. And I want to remark how we are not trying to picture the licensee as the bad guy here. So the licensee is honest, is trying to compute the proper royalty, the correct royalty, but the problem here is a problem of complexity. If a license agreement, so all the functions determine the final royalty to be paid, are too complex or dependent on complex parameter or information on the licensee side, then this is an entire process that is prone to mistakes, for mistakes to be made. And of course, this in practice, what this implies is that nowadays most license agreements are very simple and often not as fair as they could be. For example, small licensors, so startups or spin-offs, small companies, do not have the power or the infrastructure needed to manage and enforce from the licensee side say good remuneration schemes that could be beneficial for them, for their company, and often have to resort to some lump sum agreements where the licensee just pays a lump sum for the invention and that's it, and they go away with that. Of course, this does not make for a fair environment. And as an example, in practice, for example, this is a famous example in the literature where Stanford University announced that it was about to audit its licensees, and then it was flooded by payments not so inconspicuous about licensees that were doing their due diligence check and found out that they actually owed more money to Stanford than paid. Of course, in the real world, the problem is even worse because you have many licensors that interact with many licensees. So for a single product manufacturer, you have a lot of IPs inside, and the same licensor can license its IP to different licensees at the same time. And this is even more difficult when you have customers in the mix and that they can influence the royalty base. And so you have also from a licensee side to keep track about the devices, about they're managed and they're deployed on the customers. How can we solve all this? We want to use blockchain, distributed ledger technology. and in particular smart contracts. What are smart contracts? Smart contracts are simply code that let's say represents that formalizes the logic of some human written contract. In this case, the license agreement. Why do we want to use smart contracts? Smart contracts have some nice properties, and what we are more interested here is availability, which means that once you deploy the smart contract to a blockchain, to this magic computer, this distributed ledger, what you have is that the code has a life of its own, so lives on the blockchain and is always available there and beyond the control of the parties. It is immutable, which means that even if I uploaded, so if I deployed the smart contract, I am the owner of the contract, but I cannot go and change it as I like. The contract is beyond my control, and it is self-executing, which means that if I'm the one that deploys the contract has a life of its own, is not executed by me, and so I cannot influence its own execution. Why is that relevant to us? Well, because in our proposal we have a DLT and base system where the licensee, once we have broken the license agreement, the licensee computes what we have defined as bill of IP. So we have introduced this new concept to represent basically where is a parallel of a bill of material for traditional systems, where we have this a nice list of all the IPs involved in the manufacturing of a single device instead of materials traditionally is. And why do we need the bill of IP? Because the bill of IP is a structured representation of the logic of a given license agreement. So by using smart contract, we can translate the license agreement through the bill of IP formalization into a smart license, which basically is just a smart contract containing the logic of the agreement. So it is to be enforced. And why is this nice? Because then we get automated and trusted payments. Why automated and trusted? As we said, the smart license is a smart contract, so lives in the DLT and lives there beyond the control of both the licensee and the licensor that originally created it. What it means is that the logic that is now encoded in the contract is self-executing, as we said before. So whatever agreement was struck in the beginning, this is the intended logic is what is going to be executed by the DLT. So the licensor gets his royalty payments as before, but now he can trust such payments because they're not computed and managed locally by the licensee, but instead they are managed by the DLT, which in turn only relies on the code, so on the logic which is transparent written in the smart license. Another important point of our system is that if we also feed back the device usage information, so information from the customer side back to the DLT, then the DLT has access to this information, and which means that the smart license, and so the smart contract deployed in the DLT, can act upon such information, which opens us for new, let's say, business models in licensing that are not possible today, or more most of the case they're too complex to actually be carried on in practice. For example, as the pay-per-use licensing model. So a user can be asked to contribute to the payments, so to the reward of the original inventor. And of course, the main contribution of our proposal is one of simplicity. Okay, so what we have? We have the traditional system. It's cumbersome. We have manual payments. We have a lot of interaction. For example, in a big company, if the licensee, the manufacturer is a big company, they have a lot of departments that need to interact between each other to provide the proper values for the royalty base. Then these values need to be computed for in the proper way, in a timely fashion, to compute the correct royalty. And all this is overheads, is cost, and it's prone to error on the manufacturer side. And as we said before, when we introduce the DLT, we solve all these problems, and more importantly, we solve the trust issues. The inventor does not have to trust the licensee anymore to behave correctly because he trusts the DLT, he trusts the chain. What does this trust in the chain provide us? Well, basically the three properties that we saw before for smart contract translate for us in transparency in the system. The inventor, so the licensor, at each time can see what's going on, and that is being rewarded properly as intended by license agreement. The execution, as we said, relative times is beyond the control of interested parties, so cannot be tampered with, and the payments can also be automated. So it's not is beyond the licensing control, but gets automatically ported. And then we have these novel business models. This is why our proposal is both appealing from the licensee side because it prevents, it saves cost for him because it doesn't have to locally manage everything, but it's managed by the DLT, so distributedly, and it also reduces its complexity of operations. And of course, on the licensor side, so on the inventor, because then it creates trust. The inventor now doesn't have to be scared that the payments are not correct, does not need to employ costly audits because all the information is already transparent and available to him. And finally, we have the new business models, which are both novel entirely that cannot be achieved today, but as well as allowing for all the licensing agreement that in theory are today possible, but in practically they're never used due to their complexity. And I'm out of time. I will just leave you with our history, so of our project. And you see here in purple where we were lucky enough to join the pitching, and now we're presenting. And along the way, beside scientific publications, we have also started our own Alps company, and that is going on, carrying the good work, as long as our collaboration with both UK companies such as A&D and also Allboom from Arctic Alliance Technologies, as well as academic institutions such as mainly the Technical Universitat in Munich. And yeah, just 1 minute more. I've exceeded just by 1 minute. Apologies, Kate.
Thank you.
Let me open the chat. No, I see no questions. I left you speechless.
No, Alexandra has
okay,
a question.
Alexandra.
I'm
Yes.
sorry, just to open the open the floor. I've heard, I've never used it myself, but I've heard that distributed ledger, depending on which one you're using, could be very slow. So yeah, so the question is, how frequent are these transactions going to be? Do you expect them to be, and would speed be an issue?
Yeah, thank you, Alexandra. So one, scalability is an issue. Okay, of course, we have highlighted all the nice properties. There are some hidden, of course, drawbacks and costs on the system, and one of those is indeed scalability. In our approach, we use a PDL, we use a permissioned distributed ledger, which basically means that we do not use a public chain like Ethereum or Bitcoin that you may have heard about, but we use a permissioned scheme, which basically means that we have the validators are not some random Chinese miner somewhere, but they're actually entities that we know their identity already. So in this case, can be our, I mean, for now in our prototype, this is just Cambridge nodes, basically our own nodes. But in the real system deployment, then also the customer nodes, for example, the big licensee can join the network to strengthen it, of course, by retaining a little bit of control on it. And then we can spread, so introduce a small level of trust to spread the burden and, of course, make the system way more efficient. Because basically by introducing trust in the system, so you know the entity of some nodes, what you achieve is that you then can have cheaper consensus agreements. So basically DLT are run through consensus. You have a very complex distributed algorithm that runs in the background for everyone to agree on the current state of a system. So what should be written in the ledger. And if you have trusted entities, then you can, you know who, if and who is behaving, and so you can punish them, which in turn allows for, let's say, quicker consensus, because you don't have to have a lot of, mathematical proofs about its correctness in like the Wild West case, that is, for example, Bitcoin. And yeah, and also about the speed of transactions, but about royalty payments, you can have a royalty payment with as fine granularity as you want, okay? Even if in practice, most royalty payments are no more frequent than on a monthly basis, and that most of them are just a yearly payment each year and so on. which is something that we could support. For example, even pay you each hour, every hour. But in practice, if you think about the current model of one payment each month, then the number of transactions that's going on from just the payment, so the license management side is pretty low, of course, because you have one transaction each month, and the burden will actually be on let's say feeding and updating information on the DLT. So if you consider, for example, the previous case where we have consumers contributed to the DLT as well, then this device usage, push information is what will actually be the most burden. So more frequent operation.
Thank you.
If it makes sense.
Yeah, sorry to be. I don't know whether I missed something, but who's going to own the blockchain?
Okay. Yeah. Sorry. So it's my fault. I tried to give a very high bird view, let's say. So the blockchain is not owned by anyone. It's rather maintained by some entities. And in our case, being a permissioned, it is maintained by a federated set of entities that is known a priori. And of course, it's dynamic, so we can add or remove entities to this set. And in the current implementation, which is just a prototype, the IFM owns the blockchain, basically. So Alps owns the blockchain, which just means that we are only the only validators, because of course we are the only one in the system. But in a real world system, any party at stake that is willing, to dedicate, so to maintain a node, so basically dedicate some computing power to the network, then he would also join as a validator. And in this case will be the big company, the big licensees that can go and join, which is say an incentive for them to do that, as they will have direct access to the chain, and so let's say quicker and cheaper access to it.
Yeah. Would there be any sort of qualification requirements to be one of the sort of validators, or?
Yeah. So at the moment we have not introduced anything like that, because let's say we have the advantage that we can rely on the fact that if someone is misbehaving, okay, then we can we can notice that. We monitor everything is transparent, and so we can act upon it and remove them. But still, we're not allowing the permissioned model by design is not to allow anyone, any random one that wants to join, but it's going to be just someone that has a stake on the system and can prove that they can provide it without slowing everything down. Did I answer your question?
Yeah. So the answer is it's a formal sort of the requirements of what would be needed to qualify to is not formalized yet, but is that right?
Indeed.
Yeah.
Yes, we're still in an early stage of development of an actual underlying network, which is just in the prototype state.
Hi, Damiano. I've got a question about the use case. I know that you're currently obviously focusing on tracking IP, and in particular in manufacturing industry. After this system is implemented, how difficult would it be to track other types of licenses, like say media licenses?
Mm-hmm. Yeah. So thank you for the question, Max. So basically, today there are a lot of let's say proposals that regard if you could see IP and blockchain, and all of those are connected to creative industries mainly, and this is because the model in creative industries is a little different. So what often you find is that you have the creator, so the songwriter, and of course the entire band and all the musicians and everyone behind it, that go through a manager or to the producer company that then releases the product and gets the most benefit out of the product itself. While they're proposing to use blockchain to cut the middleman and just say, okay, I'm the songwriter, I can directly upload the song to the blockchain or any distribution system, and then have it managed by a smart contract instead of the producer. And so through micropayments, the user that wants to download the song can just do that directly. And so cutting intermediaries and getting a fairer retribution. This is not, I mean, it's different from our application, our use case that we're considering, because we're instead focused on manufacturing or industry, okay, in this case, IoT industry. And what you have in those industries is that we are not trying to cut out the licensee. The licensee is the one that actually manufacturing the device. The licensor is just, creating a little piece of IP that then is going to be embedded in a bigger, in a bigger product. Okay, and we're not trying to cut out licensing. So we start, our entire system starts, it comes into place when a license agreement is in place, because we just translate it and make more efficient. So that's, let's say, the different kind of approach, and that is why we're mainly focused on big manufacturing rather than creative industries, which is the more classical field of application of blockchain for IP.
Thank you.
Do we have any further questions?